Good day, I am Brittany Jane Gaabon together with Hannah Shanine Gamutin, and we'll be reporting about the Chapter 9, which is Transport Layer. Data networks and the internet support the human network by supplying reliable communication between people. On a single device, people can use multiple applications and services such as email, the web, and the instant messaging to send messages or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application and the destination device. The processes described the OSI transport layer accept data from the application layer and prepare it for addressing at the network layer. A source computer communicates with a receiving computer to decide how to break up data into segments, how to make sure none of the segments get lost, and how to verify all the segments are right. When thinking about the transport layer, think of a shipping department preparing a single order of multiple packages for delivery. The next one will be the role of the transport layer. A transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application and source host to an application and destination host. This is without regarding to the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion in a link, or the size of the network. As shown in the figure, the transport layer is the link between the application layer and the lower layers that are responsible for network transmission. TCP or IP model and how it enables application and devices to communicate. The figure highlights the transport layer, which is responsible for moving data between applications and devices in the network. The transport layer in the sending device corresponds with the transport layer of the receiving device. The transport layer responsibilities. The first one will be the tracking individual conversations. At the transport layer, each set of data flowing between a source application and destination application is known as conversation. A host may have multiple applications that are communicating across networks simultaneously. Each of these applications communicates with one or more applications on one or more remote hosts. It is the responsibility of the transport layer to maintain and track these multiple conversations. The second one will be segmenting data and resembling segments. Data must be prepared to be sent across the media in manageable pieces. Most networks have a limitation in the amount of data that can be included in a single packet. Transport layer protocols have services that segment the application data into blocks that are an appropriate size. This service includes the encapsulation required on each piece of data. A header, used for reassembly, is added to each block of data. This header is used to track the data stream. At the destination, the transport layer must be able to reconstruct the pieces of data into a complete data stream that is useful to the application layer. The protocols of the transport layer describe how the transport layer header information is used to reassemble the data pieces into streams to be passed to the application layer. The identifying the applications. To pass data streams to the proper applications, the transport layer must identify the target application. To accomplish this, the transport layer assigns each application an identifier called a port number. Each software process that needs to access the network is assigned in the transport number unique to that host. Single computer that has multiple web pages open along with an instant messaging window, an email application, a streaming video application, and VoIP phone application running. This represents that computer typically had more than one process running at any one time, and it is the transport layer that tracks each individual conversation flowing between a source application and destination application separately. Shows a series of data blocks being transmitted to the computer. The data blocks are of varying colors which correspond to different services. The computer is sending the packages to the proper application, the web browser, the email client, and the streaming video application or the VoIP phone. Each application has specific data block color. This represents the computer sorting the data based on the application. The setup and termination of data transfer session between a host and a server. We are down to conversation multiplexing. Sending some types of data, for example, a streaming video across a network as one complete communication stream can consume all the available bandwidth. This will then prevent other communications from occurring at the same time. It would also make error recovery and retransmission of damaged data difficult. A single computer has multiple web pages open along with an instant messaging window, an email application, a streaming video application, and VoIP phone application running. There is a series of data blocks of verifying colors that represent the various applications running in the computer. The series of the blocks are created by the transport layer, breaking data into segments, and each block is a segment. This is multiplexing, where multiple applications can use the network at the same time. Each data block that have error checking performed when it checked if the segment was changed during transmission. We are down to transport layer reliability. The transport layer is also responsible for managing reliability requirements of a conversation. Different applications have different transport reliability requirements. IP is concerned only with the structure, addressing, and routing of packets. IP does not specify how delivery of or transportation of the packets takes place. Transport protocols specify how to transfer messages between hosts. TCP or IP provides two transport layer protocols: Transmission Control Protocol or TCP and User Datagram Protocol or UDP. IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considerable a reliable, full-featured transport layer protocol which ensures that all of the data arrives in the destination. However, this requires additional fields in the TCP header which increases the size of the packets and also increases daily. In contrast, UDP is a simpler transport layer protocol that does not provide for reliability. It therefore has fewer fields and is faster than TCP. So what is TCP? TCP transport is analogous to sending packages that are tracked from source to destination. If a shipping order is broken up into several packages, a customer can check online to see the order of the delivery. With TCP, there are three basic operations of reliability. First is numbering um, and tracking data segments transmitted to a specific host from a specific application. Acknowledging received data, retransmitting any unacknowledged data after a certain period of time. It is an animation that shows a computer sending a file to a server using FTP application, which utilizes TCP at the transport layer. The data is segmented into 6 segments, and to start the process, 3 packets leave the computer and is sent to a router and then directed to the FTP server in a remote server farm network. The server receives the 3 packets and then it sends an acknowledgement packet back to the computer saying that it did receive 3 packets. The computer now sends the next 3 packets to the server, but they become lost in the network for some unknown reason. Since the server did not receive any packets, it doesn't send the acknowledgement. After a period of time of not receiving acknowledgement packet, the sending computer determines that the final 3 packets were not received, so it will resend those last 3 packets. The server receives them this time and will send the acknowledgement packet. Down to the UDP. So what is UDP? While the TCP reliability functions provides more robust communication between applications, they also incur additional overhead and possible delays in transmission. There is a trade-off between the value of reliability and the burden it places on network resources. Adding overhead to ensure reliability for some applications could reduce the usefulness of the application and can even detrimental. In such cases, UDP is better transport protocol. UDP provides the basic functions for delivering data segments between the appropriate applications. With very little overhead in data tracking, UDP is known as a best effort delivery protocol. In the context of networking, best effort delivery is referred to as unreliable because there is no acknowledgement that the data is received at the destination. With UDP, there are no transport layer processes that inform the sender of a successful delivery. UDP is similar to placing a regular non-registered letter in the mail. The sender of the letter is not aware of the availability of the receiver to receive the letter, nor is the post office responsible for tracking the letter or informing the sender if the letter does not arrive at the final destination. Um, It is also an animation that shows computers sending file to a server using a TFTP application, which utilizes the UDP at the transport layer. The data is segmented into 6 segments, and all packets leave the computer and are sent to a router and then directed to the TFTP server on a remote server farm network. The server receives all the packets, but since it is using UDP, no acknowledgement packet is sent from the server. We are down to the right transport layer protocol for the right application. For some applications, segments must arrive in a very specific sequence to process successfully. With other applications, all data must be fully received before any considered useful. In both of these instances, TCP is used as the transport protocol. Application developers must choose which transport protocol type is appropriate based on the requirements of the application. For example, applications such as databases, web browsers, and email clients require that all data sent arrives at the destination in its original condition. Any missing, any missing data could cause a corrupt communication that is either incomplete or unreadable. These applications are designed to use TCP. In other cases, an application can tolerate some data loss during transmission over the network, but delays in transmission are unacceptable. UDP is the better choice for these applications because less network overhead is required. UDP is preferable for applications such as streaming live video, and voice over IP. Acknowledgement and retransmissions would slow down delivery. For example, if 1 or 2 segments of a live video stream fail to arrive, it creates a momentary disruption in the stream. This may appear as distortion in the image or sound, but may not be noticeable to the user. If the destination device had to account for lost data, the stream could be delayed while waiting for the retransmissions, therefore causing the image or the sound to be greatly degraded. In this case, it is better to render the best media possible with the segments received and forego reliability. Note that applications that stream stored audio and video use TCP. For example, if your network suddenly cannot support the bandwidth needed to watch on a demand movie, the application pauses the playback. During the pause, you might see a buffering message which TCP works for a re-establish the stream. Once all the segments are in order and minimum level of bandwidth is restored, your TCP session resumes and the movie begins playing. UDP protocol properties is on the left including fast, low overhead, does not require acknowledgments and deliver data as it arrives. On the right are the TCP properties including reliable, acknowledges data, sends lost data, and delivers data in order to send. Example, UDP applications include IP telephony and streaming live video. Example TCP applications include email and HTTP. So, TCP features. To understand the differences between TCP and UDP, it is important to understand how each protocol implements specific reliability features and how they track conversations. TCP has also provides other services, such as establishing a session. TCP is a connection-oriented protocol. A connection-oriented protocol is one that negotiates and establishes a permanent connection or session between source and destination devices prior to the forwarding any traffic. Through session establishment, the devices negotiate the amount of traffic that can be forwarded at the given time, and the communication data between the two can be closely managed. Reliable delivery. In networking terms, reliability means ensuring that each segment that the source sends arrives at the destination. For many reasons, it is possible for a segment to become corrupted or lost completely as it transmitted over the network. Next one will be same order delivery. Because networks may provide multiple routes that can have different transmission rates, data can arrive in the wrong order. By numbering and sequencing the segments, TCP can ensure that these segments are reassembled into the proper order. Down to flow control. Network hosts have limited resources such as memory and processing power. When TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of the data flow. This is done by TCP regulating the amount of data the source transmits. Flow control can prevent the need for retransmission of the data when the receiving host resources are overwhelmed. Single computer has multiple web pages open along with an instant messaging window and an email application running. For core services provided TCP or establishing a session, providing reliable delivery of data, providing proper order of data sent, and managing flow control. Down to the TCP header. TCP is a stateful protocol. A stateful protocol is a protocol that keeps track the state of the communication session. To track the state of a session, TCP records which information it has sent and which information has been acknowledged. This stateful session begins with the session establishment and ends when it closed with the session termination. As shown in the figure, each TCP segment has 20 bytes overhead in the header encapsulating the application layer data. Source port 16 bits, destination port 16 bits used to identify the application. Sequence number 32 bits used for data reassembly purposes. Acknowledgement number 32 bits indicates the data that has been received. Header length 4 bits known as data offset indicates the length of the TCP segment header. Reserved 6 bits, the field is reserved for the future. Control bit 6 bits including bit codes or flags which indicate the purpose and function of the TCP segment. Window size 16 bits indicates the number of the bytes that can be accepted at one time. Checksum 16 bits used for error checking of the segment header and data. Urgent 16 bits indicates if data is urgent. The fields of the TCP header including source and destination port sequence number, acknowledgement number, header length, and window size. UDP features. User Datagram Protocol or UDP is considered a best effort transport protocol. UDP is a lightweight transport protocol that offers the same data segmentation and reassembly as TCP. But without TCP, reliability and flow control, UDP is such a simple protocol that is usually described in terms of what it does not do to compare it to TCP. The features of UDP are described in the figure. UDP header. UDP is a stateless protocol, meaning neither the client nor the server is obligated to keep the track of the state in the communication session. If reliability is required when using UDP as a transport protocol, it must be handled by the application. One of the most important requirements for delivering live video and voice over the network is that the data continues to flow quickly. Live video and voice application can tolerate some data loss with minimal or no noticeable effect and are perfectly suited for UDP. The pieces of communication in UDP are called datagrams, as shown in the figure. These datagrams are sent as best effort by the transport layer protocol. UDP has low overhead of 8 bytes. Down to multiple separate conversation. The transport layer must be able to separate and manage multiple communication with different transport requirement needs. Users expect to be able to simultaneously receive and send email and instant messages, view websites, and conduct VoIP phone call. Each of these applications is sending and receiving data over the network at the same time, despite different reliability requirements. Additionally, data from the phone call is not directed to the web browser, and text from the instant messages does not appear in the email. TCP and UDP manage these multiple simultaneous conversations by using header fields that can uniquely identify these applications. These unique identifiers are the port numbers. Computer with three different applications open the port numbers associated with each number. Next one will be the port numbers. The source port number is associated with the originating application of the local host. The destination port number is associated with the destination application and the remote host. Source port. The source port number is dynamically generated by the sending device to identify a conversation between two devices. This process allows multiple conversations to occur simultaneously. It is common for a device to send multiple HTTP service requests to a web server at the same time. Each separate HTTP conversation is tracked based on the source ports. The destination port. The client places a destination port number in the segment to tell the destination server what service is being requested. For example, when a client specifies port 80 in the destination port, the server that receives. The netstat command. Unexplained TCP connection can pose a major security threat. They can indicate that something or someone is connected to the local host. Sometimes it is necessary to know which active TCP connections are open and running on a network host. Netstat is an important network utility that can be used to verify those connections. Enter the command and address and port numbers, the foreign address and port numbers in the connection state. By default, the netstat command will attempt to resolve IP address to domain names and port numbers to well-known applications. The option can be used to display IP addresses and port numbers in their numerical form. TCP reliability order delivery. TCP segments may arrive at their destination out of order. For the original message to be understood by the recipient, the data in these segments is reassembled into the original order. Sequence number is assigned in the header of each packet to achieve this goal. The sequence number represents the first data byte of the TCP segment. During session setup, an initial sequence number ISN is set. This ISN represents the starting value of the bytes for this session that is transmitted to the receiving applications. As data is transmitted during the session, the sequence number is incremented by the number of bytes that have been transmitted. This data byte tracking enables each segment to be uniquely identified and acknowledged. Missing segments can be identified. Note that ISN does not begin at 1 but is effectively a random number. This is to prevent certain types of malicious attacks. For simplicity, we will use an ISN of 1 for the example in this chapter. Segment sequence numbers indicate how to reassemble the reorder received segments as shown in the figure. The receiver TCP process places the data from a segment in the receiving buffer. Segments are placed in the proper sequence order and passed to the application layer when reassembled. Any segments that arrive with sequence numbers that are out of order are held for later processing. Then, when the segments with the missing bytes arrive, these segments are processed in order, data being divided into 6 segments, which are each labeled with a sequence number 1 through 6 and sent to remote host. There are 5 routers connected with redundant links, thereby allowing multiple paths for segments to follow. The segments do not arrive on the destination in the same order they were sent. TCP uses sequence numbers to reorder the segments back to their original number. TCP connection establishment. In some cultures, when two persons meet, they often greet each other by shaking hands. The act of shaking hands is understood by both parties as a signal for friendly greeting. Connections on the network are similar. In TCP connections, the host client establishes a connection with the server. TCP connection is establishes in 3 steps. Step 1. The initiating client requests a client to serve a communication session with the server. Step 2. The server acknowledges the client to server communication session and requests the server to client communication session. Step 3. The initiating clients acknowledge the server to client communication session. Figure shows the steps involved in the three-way handshakes during TCP connection establishment. Step 1 shows the initiating client forming a SYN packet with a sequence number of 100 and sends the SYN request to client B. Step 2 shows client B receiving the SYN setting for the sequence, and Step 3 shows client A receiving this SYN and ACK sent by client B. This establishes the connection. TCP session termination. To close the connection, the finish FYN control flag must be set in the segment header. To end each one-way TCP session, a two-way handshake consisting of a FIN segment and an acknowledgement ACK segment is used. Therefore, to terminate a single conversation supported by TCP, 4 exchanges are needed to end both sessions. Note, in this explanation, the terms client and server are used as a reference for simplicity, but termination process can be initiated by any two hosts that have an open session. Step 1. When the client has no more data to send in the stream, it sends segment with the FIN flag set. Step 2. The server sends an ACQ to acknowledge the receipt of the FIN to terminate the session from client server. Step 3. The server sends an FIN to the client to terminate the server to client session. Step 4. The client responds with an ACK to acknowledge the FIN to the server. When all segments have been acknowledged, the session is closed. The 4 exchanges required to close the connection. The first step shown is when client A is ready to close the connection. Therefore, it sends a segment with the FIN flag set and is received by the client B. Step 2 has client B sending an ACK to client A. Step 3 is also from client B and it sends FIN to client A to terminate the server to client session and the client receives the FIN. Final step is when a client A responds to client B is sending ACK to the client B.
So OSI, or Open System Interconnection, is a computer system communicate via a network using a 7-layer paradigm. In the early 1980s, it was the first standard model for network communications, and it was adopted by all major computer and telecommunication businesses. OSI is used for a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocols. TCP, or Transmission Control Protocol, is a communication standard that allows application programs and computing devices to communicate over a network. Its purpose is to send packets across the internet and ensure that data and message are delivered successfully through networks. So for encapsulation, it is the process of adding additional information when data is traveling in OSI or TCP or IP model. The additional information has been added on sender's side, starting from application layer to physical layer. So UDP, or User Datagram Protocol, is a communication protocol for establishing low latency and loss tolerant connections between applications on the internet. UDP speeds up transfer by allowing data to be transferred before the receiving party has agreed. So the difference between TCP versus UDP are, for TCP, it is more reliable, all data received, and slower than the UDP, and it uses access more on websites. For UDP, much faster than TCP, and it also access like torrent, Zoom meetings, etc. And sometimes data won't reach to the receiver. So what is Wireshark? Wireshark is a tool for analyzing data. Wireshark is the most popular and commonly used network protocol analyzer in the world. It is the de facto standard across many commercial and non-profit organizations, government agencies, and educational institutions because it allows you to observe what's going on your network at a microscopic level. So in summary of Chapter 9, the transport layer provides transport-related services by, firstly, dividing data received from an application into segments. Second, adding a header to identify and manage each segment. Using the header information to reassemble the segments back into application data. And lastly, passing the assembled data to the correct applications. Questions and clarifications would really be appreciated. Thank you for listening.